Hello, and welcome to this presentation on the STM32 Interconnect matrix. We will cover its main features and how it is used to connect various internal peripherals. The Interconnect matrix, integrated into STM32 products, provides direct connections between peripherals. This benefits applications by ensuring predictable operation timing, reducing power consumption, and eliminating the need for complex communication management through CPU instructions. In some cases, it also avoids the need to loop signals through GPIOs from the source to the destination. The Interconnect matrix offers two key advantages. First, it enables direct and autonomous connections between peripherals, reducing latency by bypassing software handling, thus saving GPIO and CPU resources. Secondly, these interconnections remain active even in sleep mode. This slide lists the source and destination peripherals connected by the matrix. Sources include EXTIs, timers, USARTs, analog IPs, clocks, RTC, and system error. Destinations include timers, infrared interface, analog IPs, and DMA MUX. For more details, refer to the STM32C0 reference manual. This and the following slide present different use cases for the interconnect matrix. For example, it can be used to synchronize or chain timers, trigger an ADC via a timer or EXTI event, or trigger a timer based on an ADC watchdog signal when an analog input crosses a threshold. The interconnect matrix is also appropriate to calibrate HSI and LSI clocks, such as measuring the LSE frequency using a timer clocked by the internal oscillator. Other use cases include monitoring the internal temperature sensor, or VREFINT, protecting timer-driven power switches by directly connecting system error signals to the timer break input, generating infrared pulse modulation signals using two timers, and triggering DMA data transfers through a timer. This slide provides a simple example of timer synchronization. Timer 3 acts as the master timer, which can reset, start, stop, or clock timer 1, which is configured in slave mode. In this example, timer 3 clocks timer 1, effectively serving as a prescaler for it. The master mode selection field sends information through the trigger output, or TRGO, to slave timers for synchronization, such as reset, enable, update, or compare. In this case, the update option is selected. The slave mode selection field configures the slave timer's operation, including external clock mode, which is chosen here. Even in low-power sleep mode, peripherals can be interconnected using the interconnect matrix. For the STM32C0, all supported peripheral interconnections remain functional in both run and sleep modes. For more information on the interconnect matrix, please refer to the STM32C0 reference manual. You can also explore the following presentations for more details. Timers, or TIM, Analog to Digital Converter, or ADC, Extended Interrupts and Event Controller, or EXTI, DMA Request Multiplexer, or DMA MUX, Infrared Interface, or IRTIM, Reset and Clock Control, or RCC, Real-Time Clock, or RTC. Thank you for attending this presentation.